Here we've got one of those classic physics problems that you expect to see on one of these tests. So we're talking about this particle. It's moving along the x-axis. We've got a velocity equation given to us on this one. And then we've got a position is what they're asking us for. What is the position of the particle? So this definitely requires that we need to know our physics relationship, right? So there's one little bit of physics stuff that they want you to know clearly for this test. That starts us with the original function is the position function. So if I have a position function, the first derivative of position would be equal to my velocity function. And then the second derivative of position, the first derivative of velocity, is going to be equal to our acceleration equation. And as you've been going through this stuff, you've gone two directions with this. They've either talked to you about going down, taking derivatives, starting at one of these and moving from one layer to the next, or they've taught us the other direction, right? How to undo derivatives. So starting at the bottom and working our way back up. So going from acceleration to velocity or velocity to position. So the first thing you want to do when you hit one of these problems is sort of identify what layer are you at, and that'll tell you what you need to do to move up or down from there. So like we said, we are talking about velocity, and they gave us our velocity equation right here. So we are starting at the velocity level. And what are they asking us to do? Well, they are asking us to go back to the position function. So we need to go back to this position function right here. So to move from velocity to position, that tells us we're working up this chain here. So we need to take an antiderivative. We need to find the integral of velocity to get back to position. So that's where we're going to get headed on right now. So we need to go find our original position function first. So we come through, we're going to take the antiderivative of our velocity equation. So 6t squared plus 4 dt. This antiderivative here, this is just a couple of things being added, nothing special. This is just going to be our power rule. So we're going to go through our process. We're going to add 1 to the power. And then step 2 of our process is divide by that new power. So coming over here, I would add 1 to the power. That's going to get me 6t to the third over 3 plus unwritten 1 right there. I add 1 to the power. That's going to get me 4t squared over 2. And then I get plus c. So what I've just gotten back is the general solution for my position function now. If I clean that up a little bit, the 6 and the 3 can reduce down to 2t cubed plus the 4 and the 2 reduce down, giving me 2t squared. And I've got this plus c at the end though, right? And what I'm trying to do is find a specific position, which means I need to go find that plus c value. Because if I'm going to plug in 1 to my equation, I need to know what c is. And that's going to be back where this original position information comes from. This is what they call an initial value problem. So they're telling us right now that when I plug in 0 for t into my equation, I need the answer to be x equals 3. So I come through, I plug in 0 everywhere I see a t. And in the end, I know that the answer to all of that needs to be 3. This is one of those really nice ones that, the math is super quick because 0 times anything is 0. So those 0, 0, and we end up with c equals 3. So we'll take our c and we'll plug it into our general solution for c. And that's going to give us our specific solution. So we end up with 2t cubed plus 2t squared. And then instead of c at the end of this, we now plug in our plus 3. So that is our actual position function now. And so now that we've got the actual position function, now we can come back through and we can find out what's happening at the time they care about. What's happening at t equals 1. So I come over here and I take that position function and I'm going to plug 1 into it. So I want s of 1. So 2 times 1 to the third plus 2 times 1 squared, and then all of that is plus 3. And what you'll see again, because this is a calculator not allowed section, right, is that this math should be pretty straightforward to do on your own. So 1 to the third is just 1. 2 times 1 gets us 2. 1 to the second is just 1. 2 times 1 again gets us 2. And then we got our 3 sitting at the end here. So we're looking at 2 plus 2 is 4, plus 3 is going to get us 7. So we know that the position at t equals 1 was 7. So the process here, remember, with your physics problems is decide what level you're on and what level you need to get to. And that'll tell you if you need to take antiderivatives or if you need to take derivatives. And then the other side of this problem was remembering to get out your solution. That's what's called an initial value problem. You use the point that they gave you and you find where that plus c value is for your specific problem. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.